Ashe. My dear friends, I am your royal narrator, Queen Magical Melanin, extending a warm greeting to all gathered for our basic Applied Electronics Information session produced by our esteemed Elder Baba Jelani Bomani Dembe, the brilliant mind behind Majestic Mind Matters University, and the mandatory Mental Liberation series, eagerly enriching our learning journey. Today, we venture into the world of basic applied electronics, where circuits and currents intertwine to unlock endless possibilities. Let us embark on this enlightening adventure together, exploring the wonders of technology and innovation under the guidance of our distinguished Elder Baba Jelani Bomani Dembe. Welcome to a transformative experience that will ignite your curiosity and mastery in the field of applied electronics. Each moment you spend with us is a gift, a chance to grow, to learn, to be inspired. So stay with us till the end, where the true magic happens. Pay close attention and take plenty of notes to prepare you for possibly answering a few easy questions near the end of the session. In this basic applied electronic information session, you will be introduced to impedance match. Impedance match is a crucial concept in the field of electronics, especially for applied electronics technicians. Understanding impedance match is essential for optimizing the performance of electronic circuits and systems. In this essay, we will explore what impedance match is, why it is important, and what applied electronics technicians need to know about impedance match. Impedance match refers to the process of matching the impedance of a source with the impedance of a load in an electronic circuit. Impedance is a measure of how much the circuit resists the flow of alternating current. It is composed of two components, resistance, R, and reactance, X. Resistance is the real part of impedance and represents the actual resistance within the circuit, while reactance is the imaginary part of impedance and represents the effects of inductance and capacitance in the circuit. When the impedance of the source matches the impedance of the load, maximum power transfer occurs between the two components. This means that the maximum amount of power is transferred from the source to the load, resulting in optimal system performance. In contrast, when there is a mismatch in impedance between the source and load, some of the power is reflected back to the source, leading to power loss and reduced efficiency in the circuit. Impedance match is particularly important in high-frequency circuits, such as radio frequency, RF, circuits, where signal integrity is crucial. In these circuits, even small impedance mismatches can lead to signal attenuation, distortion, and poor performance. By ensuring that the impedance of the source matches the impedance of the load, applied electronics technicians can minimize signal reflections and optimize system performance. Applied electronics technicians need to be familiar with the concept of impedance match and how to achieve it in practical circuits. One common method for achieving impedance match is using impedance matching networks, such as transformers, baluns, and transmission lines. These networks are designed to adjust the impedance of the source or load to match the impedance of the other component, ensuring maximum power transfer. Another important aspect of impedance match that technicians need to consider is the characteristic impedance of transmission lines. Transmission lines have a characteristic impedance, which is the impedance that the line appears to have when viewed from the input or output terminals. In order to achieve impedance match, the characteristic impedance of the transmission line must match the impedance of the source and load. This ensures that the signal is properly transmitted along the line without reflections or losses. In addition to impedance matching networks and transmission lines, applied electronics technicians can also use impedance matching techniques such as stub tuning and quarter wave transformers to achieve impedance match in specific circuits. These techniques involve adjusting the length and impedance of transmission lines or components to match the impedance of the source and load, ensuring optimal system performance. Impedance match is a critical concept for applied electronics technicians to understand in order to optimize the performance of electronic circuits and systems. By ensuring that the impedance of the source matches the impedance of the load, technicians can minimize signal reflections, power loss, and distortion, leading to improved system efficiency and reliability. By using impedance matching networks, transmission lines, and other techniques, technicians can achieve impedance match in practical circuits and ensure maximum power transfer between components. By mastering the principles of impedance match, applied electronics technicians can design and troubleshoot electronic systems with confidence and precision. Impedance matching is a fundamental concept in the field of electronics that is crucial for ensuring optimal performance and efficiency in electronic circuits. It refers to the process of designing a circuit so that the input impedance of the load matches the output impedance of the source. When the impedance of the source matches the impedance of the load, maximum power transfer occurs, minimizing signal reflections, avoiding damage to components, and maintaining signal integrity. One of the key reasons why impedance matching is important in electronic circuits is to achieve maximum power transfer between the source and the load. When the source impedance is equal to the load impedance, the maximum amount of power is transferred from the source to the load. This is essential for ensuring efficiency in the circuit and preventing signal degradation. Without impedance matching, there may be a mismatch between the source and load impedances, resulting in power losses and decreased efficiency. In addition to maximizing power transfer, impedance matching also helps to minimize signal reflections in the circuit. When there is an impedance mismatch between the source and the load, some of the signal energy is reflected back to the source, causing signal distortion and loss of energy. By matching the impedance, signal reflections can be minimized, improving the overall performance of the circuit and reducing the risk of signal degradation. Furthermore, impedance matching is important for avoiding damage to components in the circuit. When there is a significant impedance mismatch, it can lead to excessive current flow through the circuit, potentially causing damage to electronic components. By matching the impedance, the flow of current is optimized, reducing the risk of component damage and ensuring the longevity of the circuit. Another key reason why impedance matching is essential in electronic circuits is to maintain signal integrity. In applications where signal quality is critical, such as in high-speed data transmission or audio systems, impedance matching ensures that signals are transmitted efficiently without distortion or loss of quality. By matching the impedance, the integrity of the signal is preserved, allowing for clear and reliable communication between devices. Overall, impedance matching plays a crucial role in optimizing the performance and reliability of electronic circuits. It is important for maximizing power transfer, minimizing signal reflections, avoiding damage to components, and maintaining signal integrity. Applied electronics technicians need to have a solid understanding of impedance matching principles and techniques in order to design and troubleshoot electronic circuits effectively. Impedance matching is a critical concept in electronics that is essential for ensuring efficient and reliable circuit performance. By matching the impedance of the source and load in a circuit, maximum power transfer can be achieved, signal reflections can be minimized, component damage can be avoided, and signal integrity can be maintained. Applied electronics technicians should be well-versed in impedance matching principles and techniques to optimize the performance of electronic circuits and ensure the successful operation of electronic systems. Impedance matching is a crucial concept in the field of electronics, especially for applied electronics technicians. In any electronic circuit, components may have different impedance values, which can lead to signal reflections, loss of power, and inefficiency. An impedance mismatch can cause a variety of problems such as signal distortion, signal loss, and reduced transmission efficiency. To overcome these issues, technicians need to understand various methods and techniques that can be used to achieve impedance matching in electronic circuits. One of the commonly used tools for impedance matching is a transformer. A transformer can be used to match the impedance between two different parts of a circuit by altering the voltage and current levels. By choosing transformers with appropriate turns ratios and winding configurations, technicians can effectively match the impedance between the input and output of a circuit. Transformers are particularly useful in situations where there is a significant mismatch between the source impedance and load impedance. Another common method for achieving impedance matching is the use of resistors. Resistors can be used to adjust the impedance in a circuit by providing a specific resistance value that matches the impedance of the components. By selecting resistors with the right resistance values, technicians can effectively match the impedance and minimize signal reflections. Resistors are often used in combination with other components such as capacitors and inductors to create matching networks that optimize the overall impedance in a circuit. Capacitors and inductors are also key components that can be used to achieve impedance matching in electronic circuits. By adjusting the values of capacitors and inductors in a circuit, technicians can create matching networks that transform impedances and improve signal transmission. Capacitors can be used to block certain frequencies and pass others, while inductors can be used to create impedance transformations. By combining capacitors and inductors in various configurations, technicians can create custom matching networks that are tailored to the specific impedance requirements of a circuit. Transmission lines with specific impedance values can also be used to achieve impedance matching in electronic circuits. By selecting transmission lines with the right impedance values, technicians can minimize signal reflections and optimize signal transmission efficiency. Transmission lines are commonly used in high-frequency applications to ensure proper impedance matching and signal integrity. Matching networks, such as L-section, T-section, and pi-section networks, are another useful tool for achieving impedance matching in electronic circuits. These networks consist of combinations of capacitors, inductors, and resistors that are arranged in specific configurations to transform impedances and create a perfect match between the input and output of a circuit. By designing and implementing matching networks, technicians can achieve optimal impedance matching and improve the overall performance of electronic circuits. The Smith chart is a graphical tool that is commonly used in the design of matching networks and impedance matching in electronic circuits. The Smith chart provides a visual representation of complex impedances and helps technicians analyze and optimize matching networks. By using the Smith chart, technicians can design custom matching networks that meet the impedance requirements of a circuit and ensure efficient signal transmission. In conclusion, impedance matching is a critical concept that all applied electronics technicians should understand. By using tools such as transformers, resistors, capacitors, inductors, transmission lines, matching networks, and the Smith chart, technicians can effectively achieve impedance matching in electronic circuits. By optimizing impedance matching, technicians can improve signal transmission efficiency, reduce signal reflections, and enhance the overall performance of electronic systems. Thanks for your participation in this special Majestic Mind Matters University Basic Applied Electronics Information session. I am your royal narrator, Queen Magical Melanin. Here is a special message from our esteemed elder Baba Jelani Bamani Dambe, the brilliant mind behind Majestic Mind Matters University. To all applied electronic technicians, he wants you to know this. Your participation with Majestic Mind Matters University has been invaluable. Your expertise and commitment to excellence has elevated our research and knowledge in the field of applied electronics. Thank you for choosing Majestic Mind Matters University as a trusted source for your valuable applied electronics information to aid to your success with this basic applied electronics information session titled Introduction to Impedance Match. Stay woke. Ashe.